Yeah. Good morning, guys, and welcome to interview preparation session, which is conducting by 360 DGTMG. So, in today's session, we'll just go across some of the questions which have been recently asked in some of the interviews by some of the interviewers. So, the first question for the day, guys: explain the steps in making a descent tree. Like, how does a descent tree is done? Like, what were the steps to make it? So, if anyone knows the answer, try to ping me in the chat box, and we'll discuss the answer within a minute. Yeah. So as we look into this, take the entire data set as an input. Then you have to calculate the entropy of the target variable. So which have been kept as well as predicted attributes. So and then you can calculate the information gain of all the attributes. Then you can choose those attributes what's the highest information gain in the root node. And you have to repeat the same procedure for each and every branch until the decision node of each branch is fine. So as we jump into the next question, how can you avoid overfitting your model? So if anyone knows the answer, try to ping me in the chat box and we'll discuss the answer within a minute. Yeah. So as we look into this overfitting, it refers to a model which that is only set of some required variables and amount of data, which ignores some bigger pictures. So three main methods to avoid this overfitting in a particular format. So you have to keep the model very simple and take fewer variables into the account. Therefore, by removing some of the noise in the training data, use cross validation techniques like k-folds cross validations. Use regular techniques such as lasso rates, certain model parameters to avoid these kind of overfittings in the model. So as we jump into the next one, what are dimension reductions and their benefits? So if anyone knows the answer, try to ping me in the chat box and we'll discuss the answer within a minute. Yeah. So as we look into this, the dimension reduction refers to process of converting a data set with vast dimensions, irrespective to their fewer dimensions. So to convey this similar information consistently, so the reduction it helps to compressing data and reducing storage spaces, computations, and it takes very less space for computing. So it removes all the irrelevant things, like it removes all the relevant features which have been they've been declared inside them, right? So all the things which have been they have been declared in the values of two different units. So as we jump into the next question, how should you maintain a deployed model? So if anyone knows the answer, try to ping me in the chat box and we'll discuss the answer within a minute. Yeah. So as we look into this, how should you maintain a deployed model? So these steps should be followed to how to maintain a deployed model. So you have to monitor it, you have to evaluate, you have to compare, and if it is not performing good, again you have to rebuild it. So monitoring, what comes under this? So monitoring of all these models is need to determine their performances, accuracies. When you change something, you want to figure out or how your changes are going to affect things and all. Those will be monitored in this monitor part. So evaluate. So you'll evaluate all the metrics of current models as calculation to determine whether it's a new algorithm or it's needed and all. So comparison, you have to compare this new model with some other models like some other preferred models to get the best results. So rebuild it. So if you're not getting it, you have to again rebuild it. So as we jump into the next one, how can you select K from K mean? So if anyone knows the answer, try to ping me in the chat box and we'll discuss the answer within a minute. Yeah. So as we look into this, we can use elbow method to select this K-means clustering. So the idea for this K-means clustering of data set where K is nothing but a clusters. So with the sum of the squares, it is defined the sum of square distances between each member and the clustering part as along with centroid. So as we jump into the next question, how can outliers values are treated? So if anyone knows the answer, can ping me in the chat box and we'll discuss the answer within a minute. Yeah. So now as we look into this, how can you treat the values of outlier? So you can drop outliers on the only if there are a garbage value. So example, suppose if you have been taken in a adult height, like will just measure the height in feet, right? So that this cannot be true, as height cannot be string values. So in this case outliers can be removed. So if the outliers have some extreme values, if in case if they do have some any extreme values, so then what you have to do is the process, you have to remove them, and for example you have to even cluster between 0 to 10, and the point line should lies on 100. So if you cannot drop those outliers, you can try the following, like you can even go with try a different model, like data detection as outliers by linear models can be fit using non-linear models. Therefore we have to be sure for what we have been choosing, we have choosing whether we are choosing a correct model or not. We have to try the normalizing the data this way, and we have to even pull the points of the similar ranges, so you can use algorithms that are less affected by outliers, and that would be a random forest. So as we jump into the next question, so you are given a data set on cancer detection, and you have built a classification model and achieved an accuracy of 96%. So why shouldn't you be happy with your model performance? So what might be the reason? So if anyone knows the answer, try to ping me in the chat box and we'll discuss the answer within a minute. So as we look into this, a cancer detection results in imbalanced data because accuracy should not be based on the measure of performance. So it is important to focus on the remaining 4%. Like if we got on a 96% accuracy, right? So which represents the patients who are wrongly diseased or early diagnosed is crucial when they haven't detected the particular cancer and all. So it can be greatly improve the patient's progress, right? Hence, to evaluate model technology, we should use sensitive specificity measures, which measures to determine the class wise performance to a classifier. So as we jump into the next one, we want to predict the probability of death from heart disease based on three different factors: age, gender, and blood cholesterol. So, among this, what might be the best appropriate algorithm? And the options are logistic regression, linear regression, k-means clustering, and appropriate rule. So, if anyone knows the answer, try to ping me in the chat box and we'll discuss the answer within a minute. Yeah. So, as we look into this, and the right answer for this is regression, logistic regression, and it's the most appropriate algorithm for choosing such kind of statements at all. So as we jump with the next question, after studying the behavior of a population, you have identified four specific individual types that are valuable to your studies. Okay, you should like to find all users who are most similar to each individual type. So which algorithm is the most appropriate algorithm for this kind of studies? And the options are k-means clustering, linear regression, association rules, and decision tree. So if anyone knows the answer, try to ping me in the chat box and we'll discuss the answer within a minute. Yeah. So if we look into this, if we look into this, as we are looking for grouping people together specifically by four different similarities, it indicates the value of K, where K means clustering is one of the appropriate algorithm for these kind of studies. So as we jump into the next question, what are the feature vectors? So if anyone knows the answer, try to ping me in the chat box and we'll discuss the answer within a minute. Yeah. So as we look into this, a feature vector is an n-dimensional vector for numeric features which represents an object. So in machine learning featuring, they are used to represent some numericals and some symbolic characters of an object in a mathematical way. So which is easy to analyze. So as we jump into the next question, what is logistic regression? So if anyone knows the answer, try to ping me in the chat box and we'll discuss the answer within a minute. So as we look into this logistic regression is also known as a logic model, and it's a technique which is used to forecast the binary outcomes from a linear combination of predictor variables. So as we jump into the next question, what are recommendation systems? So if anyone knows the answer, try to ping me in the chat box and we'll discuss the answer within a minute. Yeah. So as we look into this, what are these recommendation systems? So these are subclasses of informing filtering systems that are meant to predict the preferences or ratings that users would like to give for a product. So as we jump into the next question, explain cross validation technique. So if anyone knows the answer, try to ping me in the chat box and we'll discuss the answer within a minute. So as we look into this cross validation is a model validation technique which is used for evaluating how the outcomes of an statistical analysis will generate to an independent data set. So this is mainly used in backgrounds where the objectives is to forecast and one wants to estimate how accuracy a model is. So as we jump into the next one, what is collaborative filtering? So if anyone knows the answer, try to ping me in the chat box and we'll discuss the answer within a minute. As we look into this, most recommended systems will be using this filtering process to find the patterns and information by collaborating perspectives, numerous data sources, and several agents. So, as we jump into the next one, what are the drawbacks of this linear model? So, if anyone knows the answer, try to ping me in the chat box and we'll discuss the answer within a minute. So, as we look into this, the assumptions of linearities of the errors, it can't be used for count outcomes or binary outcomes, and there are overfitting problems that which can't be solved. So, as we jump into the next one, how regularly must an algorithm be updated? So, if anyone knows the answer, try to ping me in the chat box and we'll discuss the answer within a minute. As we look into this, you will want to update an algorithm when you want to model to evolve as a data stream through infrastructures and the underlying data source is changing and there is a case of non-stationarity. So in those cases you may get updated your algorithm. So as we jump into the next question, why is resampling done? So if anyone knows the answer, try to ping me in the chat box. So as we look into this, why should we do this particular resampling? So for estimating the accuracies of sample statistics by using the subsets of accessible data or drawing randomly with the replacement from a data points. So and substituting labels on data points when performing significant tests on and validating models by using random subsets. So we do have different conditions to use this resampling. So these were some of the conditions. So as we jump to the next one, what is section bias? So selection bias. So if anyone knows the answer, try to ping me in the chat box and we'll discuss the answer within a minute. as we look into this, what is the selection bias? This selection bias is, in general, is a probabilistic situation in which errors is introduced due to some random, non-random population sample. So this is how this selection bias does. So as we jump into the next question, what are the different types of biases that can occur during the sampling? So if anyone knows the answer, try to ping me in the chat box, and we'll discuss the answer within a minute. So yeah, as we look into this, what are the types of biases? Like there are selection bias, undercoverage bias, and survivorship bias. So these were the three types of biases which we work on. So as we jump into the next question, what is survivorship bias? So if anyone knows the answer, try to ping me in the chat box, and we'll discuss the answer within a minute. Yeah. So as we look into this, this survivorship bias is an logical error which focus on aspects the support of surviving a process and casually overlooking those that did not because of their lack of prominences, and this can lead to wrong conclusions in numerous ways, like n number of ways. So yeah, that's it for the day, guys. Thanks for joining the session. Hope you have a great day, and we'll meet in the next session. Thank you, guys. Bye.